So I return to the model of Einstein. Einstein proposed that the radiation is a flow of particles called photons. The energy of the photon is equal h nu, and the total energy of the radiation is equal to the number of photons n times h nu, which is the energy of one photon. So what is the proof of the Einstein model? We have the photoelectric effect. What is the photoelectric effect? And this is the experiment of Einstein. If you have a metallic piece and this metallic piece is submitted to a radiation of known energy. When we say that the radiation is of known energy, we can say also that the radiation is of known frequency mu and of known wavelengths lambda, since the energy of the radiation proportional to the frequency of this radiation, E equal h nu equal hc over lambda. So E, mu, and lambda of the same radiation are related. Einstein observed that when a radiation is submitted, when a metallic piece is submitted to a radiation, we have emission of electrons from the surface of the metallic piece. So electrons are emitted from the surface of a metallic piece when the light of known energy or known frequency or known wavelengths strikes it. The following observations characterize a concept, which is the photoelectric effect. So what is the photoelectric effect? Is the process of emission of electrons from a metallic piece by striking energy to this metallic piece. This is the photoelectric effect. And he observed, Einstein has many observations in his experiment. Do we have emission of electrons for any value of E? No. He observed that the emission of electrons from the surface of the metallic piece is possible only for a certain value of the energy. So when the frequency of the light is changed, he observed sometimes we have emission of the electrons. For other frequencies, no electrons emitted. So he concluded that the electrons can be ejected from the metallic piece if the value of energy E that strike the metallic piece is greater than a certain value of energy of the metallic piece we called E0, that we called the threshold energy. Or by other way, a radiation of frequency mu greater than mu0 of the metallic piece we call the threshold frequency. So in this case, we have releasing of electrons. Or if the radiation has a value of lambda greater than lambda 0 of the metallic piece, we have ejection of electrons from the metallic piece. So for frequency of energy lower than the threshold frequency of the metallic piece, no electrons are emitted. For a frequency greater than the threshold frequency, we observe that we have emission of the electrons. For a frequency greater than the threshold frequency, the kinetic energy of the electron increases with the frequency of the light. As a conclusion, what is the photoelectric effect? The photoelectric effect is the ejection of electrons from a metallic piece due to the irradiation of this metallic piece by external radiation. The external radiation is characterized by energy E, by frequency mu, by wavelengths lambda, and the metallic piece is characterized by threshold energy E0, which is constant according to the type of the metal, or of mu0, which is the threshold frequency of the metal, which is constant, or according to lambda 0, the threshold wavelengths, which is constant. If E of the radiation that strike the metallic piece is greater than E0, or in other words, if mu of the frequency is greater than mu0 of the metal, or if lambda of the radiation is greater than lambda 0 of the metallic piece, we observe ejection of electrons from the metallic piece. So the photoelectric effect could not take place if E is not greater than E0. This is the condition of the photoelectric effect. So photoelectric effect is the ejection of the electrons. The condition of the photoelectric effect, the energy of the radiation that strike the metallic piece should be greater than the threshold energy of the metal, and E0 is constant for a certain metal. The principle of conservation of energy will say that we have total energy constant. So the energy that strikes the metallic piece is divided two parts. A part is responsible for the ejection of the electrons, and when the electrons are ejected from the metallic piece, they have kinetic energy. So the principle of conservation of energy, E total, is equal. We say that a part is responsible to remove the electron from the metal, so is equal to E0 of the metallic piece plus E kinetic. So as a conclusion, the total energy of the radiation that strike a metallic piece is equal to the threshold energy of the metallic piece, which is constant, plus the kinetic energy of the electron ejected. What is